All right, Mike, back to you.
Okay, well, thank you, Isaac. Informative. Sheryl, would you like to jump in here and offer a state viewpoint in any of this so far?
No, I want to thank you so much for letting me participate and be here. I really appreciate that. I have had the opportunity to go through the aspects report, not dig through the data that supports it, but it looked like it was very well done, and you're fortunate that you have that as a basis to build on. And it's just seemed like an excellent report. So thank you.
Well, thank you, Sheryl. And looks like we're building some Q&A for after the presentation. Everybody will have a chance to jump in here and ask your questions, so be patient. Anyway, next slide. Percent of Lummi Island wells with elevated chloride levels. What's all this business of chlorides? Oh my goodness. Well, if we look at the studies going back to 1978, very few wells, but only one of them showed chloride levels. In 91 and 94, it was 10%. In 94, they included some of those wells that had elevated, the 100 part per million level. And then in 2005 and 6, if you look at the combined wells that are over 100 and the ones that are over 250, it looks as though those graphs are growing quite alarmingly, but in actuality, only 5 of 130 is less than in 91 and 94. I guess the only thing to draw from this is that too few studies over too long a period of time. And you see the big question mark over there on the right-hand side. And this is what the Watersafe program is all about. It's been 16 years since we've tested our wells. We've added population to the island. Climate is changing about us, and we'll talk about that here in a little bit. So where are we? Should we be concerned, or should we be just fat, dumb, and happy? And if your well runs dry or gets contaminated, oh well. That's a bad pun. I'm sorry. I didn't mean to say that.
You're going to let me loose on puns. Okay. Another thing about this Watersafe challenge is that we want to have a larger sample size, right? So even if you know that your well is doing great and you're not worried about seawater intrusion, we'd love to have you participate, because if we're only testing fragile wells, it's going to throw the data off too.
So next slide. Let's talk about this chloride indicators and greater than 100, greater than 250. EPA sets standards for maximum contaminant level of all sorts of things that should not be in your water at certain levels. And they set that contaminant level at 250 parts per million. Salt water is in the thousands, 20, 30,000 parts per million. So, but all of that salt and chloride is not healthy. And that's why they set that. You look at the graphic, that little red house with a well going down in it, kind of simplify that up. Before the house and the well, it was just a big blob of fresh water, kind of hovering near the shore, extending inland. And the top of the well of that fresh water was somewhere around sea level and extended down. And we had nice vegetation and trees and all kinds of wildlife, and life was good. We started building these red houses all over the place and drilling wells, and started sucking fresh water out of the ground. And there's a balance between the fresh water that's below us holding back the salt water, essentially leaking out. And that's what Dr. Schmidt was talking about when he said the fresh water leaks out and has to be replenished by infiltration, by the 2 inches of rain that we get. It's a balance. And we know that Lummi Island is a big jumble of rocks and gravel and sand and clays and all sorts of things. Some are tilted up and some are fractured, and good luck trying to figure it all out. So it's very dependent upon where you're at. I know everybody's looked at the maps and said, where do I live? I guess I'm okay. Or, oops, maybe not. And it depends upon how many of those red houses have wells and septic systems and how dense it is and how much they're pumping. And that's the kind of stuff that we want to educate islanders on, how they can underpump their freshwater supply, where you don't get these cones of depression, where you likely start sucking air out of your well, or a cone of ascension, whereas you pump hard for long periods, you start to draw that salt water up into the intakes. And once it gets in there, it's really difficult to get it back out because the tidal flows, it's all mixing and dependent on how close to the shoreline you are. So the only thing to take away from this slide is we don't want to overpump our wells in singly or in combination. We want to test our individual wells for what are we actually pulling in. That's good information to know. There are other tests that we can do, conductivity and total dissolved solids. And, there's tools in the toolbox if we avail ourselves of them. So